4.4 is problems in 2 dimensions. Now, these problems are generally going to include triangles because it's a trigonometry chapter. And they're going to be pretty similar to last year when you experienced problems, except you have something called the ambiguous case this year. So what's an ambiguous case? It's a problem that has more than one solution, and you're going to see when that occurs. A pretty easy way to determine that is this right here. If you have 2 sides and an opposite angle for trig, you have an ambiguous case. Here's an example. If you have these 2 x's, these are the sides you have, and any one of these opposite angles, so not the angle subtended by the 2 sides that you have, you want one of the other angles. This is ambiguous every single time. So when you're looking for this, you can kind of see this with the sine law existing here. You need to actually do the question twice, basically, one for one solution and one for the second solution. So we're going to see that in our next example. So again, this is how it looks. Remember, if you have this angle, you have cosine law, side angle side, or that crocodile or Pac-Man mouth. This always tells us about cosine law. And if we have an angle with its opposite side length, this is always going to be sine law. So just some reminders on cosine and sine law. SOHCAHTOA reminder, when you have a right angle triangle, so some right angle trig, this is from grade 10 as well. If you want to find this x value, okay, we're going to look at the labels of the sides relative to the angle. So this side is the opposite, this side is the adjacent, this side is the hypotenuse. I have the adjacent, I'm looking for the hypotenuse, so I have to use cos because ka. Cos theta equals a. The angle is 35, and I don't know what h is. Okay, and when I'm solving for the variable at the bottom, I just replace with cos 35, plug that into my calculator, and get my answer in meters. Okay, and that's it. Right angle trig, very elementary. Make sure you don't make a mistake with this because it's as easy as it gets. Okay, and the next example will be our sine law example. All right, so the hardest problems in math, and especially in trig, is going to be drawing the diagram. So you're going to get a bunch of words with a bunch of directions and angles and lengths, and your job is to create a triangle from this, or a diagram, in order to determine which side length or angle you need to find. So let's take a look at this question. A lighthouse at point L, so we want point L, is 10 kilometers from a yacht at point Y. So if I draw a yacht, now this angle, I'm just guessing, right? I don't know exactly where it is or what the values are. I'm not doing this to scale. I don't really care. But I know that this is 10 kilometers just from that first phrase. So a lighthouse at point L is 10 kilometers from a yacht at point Y, and 8 kilometers from a sailboat. So let's go the other way. So a lighthouse is also 8 kilometers from a sailboat. We'll call it B, at point B. Now I can create my triangle, right? I know they're going to connect. From the yacht, the lighthouse and the sailboat, so from Y, the lighthouse and the sailboat are separated by 48 degrees. So if it says from with the degrees, that's the letter that's going to take the degrees. So this is 48 in here. Okay, and I've pretty much drawn my diagram. Find the distance between the lighthouse and the sailboat. I need to find this distance right here. Now, the first thing we have to do is we have to determine whether we have an ambiguous case or not. Now, how do we know if we have an ambiguous case? We're going to have side, side, opposite angle. So I have these 2 sides, right? These are the sides I have, but I don't have the angle in between them. I have an opposite angle. Therefore, I have an ambiguous case, which means I need to solve this question twice. One for an acute angle B and one for an obtuse angle B. And I'm going to show you why there's actually 2 solutions. Let's just solve it. Actually, no, I'll draw it right now. So, why is there an ambiguous case? Look at the second thing that can happen here. This length of 8, right? I don't know where it's going to be. This makes sense that it's going to be like this, but it could also be in here. Now, why can it be in here? It's because it could still be 8, right? So picture this length going in. Now it's too long for the triangle, it's too long for the triangle, and then eventually it's going to be just right for the triangle, right? Because it's less than 10, so eventually it's going to make its way inside and not be longer, right? Maybe around here somewhere. So this right there is also an option where this is 48 in here. Okay, this is Y, this is L, this is B. This is 10, this is 8, everything's the same except this angle changes because I don't have any angles here that are locking this figure in. So this is rotating in, and I have, so that's 48, and this angle over here is going to be the supplementary angle of the first B that I find. Okay, so creating these two diagrams could seem a little difficult, but once you find out this angle, it's just 180 minus that angle for your second diagram. There's not much to it. Okay, so let's solve this thing. First things first, we need to find, using sine law, angle B. Okay, so I'm going to use blue for this case right here, and I'll probably do it over here. So I want to find B. I'm going to use sine B, sine law, over 10 is sine 48 over 8. I always start with whatever I'm solving for. So I know sine law sometimes has a side lengths on top, but because I'm finding the angle, I'm putting the angle on top. Sine B over 10, and then sine of 48 over 8. I can rearrange this. And then solve for B. Right? I don't want to put this in my calculator yet because I only like to pick my calculator up once. Okay, so I'm going to put that in my calculator, find sine -1 of that, and I'm going to get approximately 68 degrees. That's a very key angle. That's going to be angle B right there for the blue diagram. Okay, and now that I have angle B, I have two angles. I can find angle L using sum of interior angles. So I know that angle L, and these are angles by the way, angle L is going to be 180 minus 68 minus 48, so angle L is going to be 64 degrees. Okay, I'm progressing pretty well now. I just did one sine law, one sum of interior angles, and I'm almost done. The only thing I'm missing now is the actual answer. Now, why do I need angle L? I need angle L because in order to do sine law to find x, I need the angle. I can't find a side length without the angle for sine law because I need to complete a full ratio. Okay, so now I'm going to do sine law with L, but instead I'm going to find x over sine of L, which is 64, equals 8 over sine 48. Okay, notice I'm using the same ratio, the ratio that the question gave me. That's max accurate if you can use the ratio that the question gave you. Instead of my 10 and B, because I kind of estimated this, I'm going to use the one the question gave me. I'm going to do the same thing, multiply this sine up here, and then I'm done. So 8 sine 64, I'll write it down. And x is going to be 9.7 kilometers. And this is my final answer for this diagram right here. Now, how do I solve this answer? This answer, the only difference is going to be my B is going to be the supplementary angle of 68. So I'm going to go over here and just say 180 minus 68 equals 112. So my B for this diagram is 112, which makes my L 180 minus 112 minus 48. My L becomes 20 degrees. Okay, so a lot just happened right there. I just found the supplementary angle of 68, then found L using that new value, and now I can continue with my final sine law using my new angle of L. It's kind of like this. X over sine of 20 equals 8 over sine 48, blah, 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 3.7 kilometers. So my answer could be 3.7 kilometers or 9.7 kilometers. There's really not enough information to say that there's only one answer, so we have to account for both answers in this ambiguous case. Okay, so there's a lot going on over here. Maybe watch the video a few times. If you forgot how to do sine law, write it in the comments or something, because I know it's grade 10 stuff, but we definitely have to know how to do sine law and cosine law. I'm going to do next. in order to succeed in this chapter. All right, so for our cosine example, I'm going to use a little diagram. Let's say you're here and you know your buddy is 220 meters away this way, and your other buddy is 280 meters this way. So we can label our side lengths. This means that this is 280, and it means that this side is 220. Now, you also know that they are separated by an angle of 30 degrees. So what you want to do is you want to find out what the value of x is. How far away are your two buddies? Okay, so that's not information that you can gather from your position, but as long as you know how far one is and how far the other is and what angle separates them, you can find out how far apart they are. Now, this is pure cosine law because of this information right here. Side, angle, side. When all the information is kind of stacked like Pac-Man's mouth, side, angle, side, it's always cosine law, and you have to find the opposite side length. Okay, so it's a big tell when all the information is stacked on one side. So, what is cosine law? So for cosine law, let me just remind you what the formula is. It's a squared equals b squared plus c squared minus 2bc cos of a. Okay, so these letters don't really matter as long as the side length you're trying to find is on the outside here and all these letters match. So b and c, whatever these are also here. This angle is always the capital letter of this side length. Everything else is kind of status quo. Okay, so let's plug everything in. So these are the side lengths you know, the 220 and the 280. 220 squared plus 280 squared minus 2, 220, 280 cos 30. Okay, so a lot going on over there. Now, I'm going to square these and add them, and I'm going to get 126,800. And I'm going to multiply these three things together and leave the cos 30 there, just so you can see what I'm doing. Okay, because a very common mistake is for you guys to subtract these two numbers now. But this is multiplication, right? And BEDMAS says we got to multiply this by the cos 30 first. So that's what I'm going to do. I'm going to multiply by the cos 30, and I'm going to get... And now I can finally subtract. And now I can square root, right? Because this is a squared. And I'm going to get 141.8 meters. Okay. There is a way to do this, in one step. You can just plug this into your calculator, then find the square root in one step. I just wanted to show you the process. This is a, by the way. It is the x value. And we found our missing side length in a non-right angle triangle using cosine law. Okay, so remember this is cosine law. Now, I just want to say one thing without doing an example. We can also find an angle using cosine law if we're given all three sides. Okay, so cosine law is either you have this angle in here or you have its side length, its buddy on this side. If you have all three angles, you're going to have this number right here. You're not going to have this letter. So you're going to have to eventually move everything over to one side or use the formula that solves for an angle and solve for that missing angle using inverse of cos. Okay, so you have to practice finding a side length and finding an angle for cosine law. You will definitely need cosine law for 4.4 and 4.5, problems in 2 and 3 dimensions. Okay, so practice it, perfect it. It's not that hard.